chapter 10. And so this is the last chapter for the 142 class. So chapter 10 deals with conic sections. So first off, parabola. So y squared equals 4a to the x, or x squared equals 4a to the y. So what do these look like? Well, so one would be a parabola going like this, and the other one's a parabola going like that. So in the case of this one, if A is positive, it opens right. If A is negative, it opens left. In this one, if A is positive, opens up, and if A is negative, it opens down. And then you get in terms of the more general form of it, and so you get to the vertex form, which can either be y minus k squared equals 4a x minus h, or x minus h equals 4a y minus k. And so here the vertex is given by hk, and the focus is h plus a k. And then for this one, the vertex is hk, and the focus is hk plus a. So given something like this, x minus 3 squared equals 12 y plus 5. So we know that h is 3, k is a minus 5, and we have that 4a is equal to 12, which means that a is going to be 3. So my vertex is at 3 minus 5, and the focus is going to be at 3 minus 2. So that is my parabola. Well, then the next one they talk about is an ellipse. And so it could be in this form, a squared, y squared over b squared equals 1. Or it can be y squared over a squared, x squared over b squared equals 1. And the thing that's true for both of these is that c squared equals a squared minus b squared. Well, what does this mean for my ellipse? Oops. Well, what this means is that for this one, this is an ellipse running this way. So the major axis is the x-axis, and then this one is an ellipse running this way, and so the major axis is the y-axis. Well, then we could get and turn again and turn the more general form, and so now we got x minus h squared over a squared, y minus k over b squared, or we could have, it'll be this way, x minus h over b squared, y minus k over a squared equals 1. So let's look at an example of one of these. So let's say I have this one, x minus 4 squared over 25, y minus 3 over 16 equals 1. Right? So what do we know? Well, we know h is 4. We know k is 3. We got that a squared is equal to 25, which means a is 5. We got b squared equals 16, which of course means b is 4. Right? And then we got that c squared is going to be 25 minus 16. C squared equals 9, which of course means c is 3. So in regards to this one, then, we have that the center is at 4, 3. The vertices are going to be at 9, 3. And then at minus 1, 3. And then going the other direction, we're going to be at 4, 7, and at 4, minus 1. Right. And then my two foci will have one at 7, 3, and the other one at 1, 3. We can talk about the length of the major and minor axis. So the length here of the major is going to be 10, and the length of the minor is going to be 8. And then the next conic they talk about is a hyperbola. And so the general form is x minus h squared over a squared minus y minus k over b squared equals 1, or y minus k squared over a squared x minus h squared over b squared equals 1. So my hyperbola then is something that looks like this. So we get something that's going like that, and then like that. Would be a hyperbola. Well, then in terms of a general form of an equation, can we tell what it's going to be? So doing a general form. So a couple. One is if it's in this form, ax squared plus cy squared plus dx plus ey plus f equals 0. And a and c do not equal 0. So what happens here? So if a times c is equal to 0, then we have a parabola. If a times c is greater than 0, then we have an ellipse or a circle. And then the third case is if a times c is less than 0, then we have a hyperbola. And then the other case for my general form would be if I now have one that looks like this. So ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And so now it's in this form. If b squared minus 4ac equals 0, then we have a parabola. If b squared minus 4ac is less than 0, then we have an ellipse or circle. And then if b squared minus 4ac is greater than 0, then it is a hyperbola. Well, other ways of writing our polar equations is we can rewrite them, our conic equations. We can write we can have a polar form. And so R equals EP over E cosine theta. And so E has to do with how eccentric the curve is. So if E is equal to 1, we have a parabola. E is less than 1. We should redraw that. So if E is less than 1, then we have an ellipse. And if E is greater than 1, we have a hyperbola. So given something like this, R equals 3 over 4 minus 2 cosine theta. Well, it doesn't match our form because we want it to be in terms of a 1 there, 1 minus e cosine. So what we can do is take everything divided by 4. And so R is going to equal 3/4 over 1 minus 1/2 cosine theta. Now we match. And so from here, we can now see that E is 1/2, which means we have an ellipse. And then the chapter finishes off talking about parametric equations. So parametric equation really has to do with respect to time. So let's say I have, in terms of this scenario, I have a projectile. We're going to give it a speed of 145 feet per second at a 20-degree angle. And it's initially 5 feet off the ground. So we want to know what's happening to this thing in terms of its x and y position over the course of time that is in the air. Okay? Well, the velocity in the x direction is going to be given by v naught cosine theta. The velocity in the y direction initially is x naught and vy naught. Is going to be v naught sine theta. So this will be 145 cosine of 20. So this gives 136.26, and this is 145 sine of 20. And so this gives you 49.59. And both of these will be feet per second. Okay. So where's the position on my object then? Well, x sub t, the position relative to time, is given by the velocity in the x direction times the time. Okay. And then the y direction, okay? Well, y, we have gravity pulling this down. And so here, y is going to be the initial velocity in the y times t minus 1/2 g, which is 32 feet per second squared, times t squared, plus the initial height it started at. So this is going to be 49.59 t minus 16 t squared plus 5. And this is going to be y sub t. Okay? So x position, y position with respect to any time t. Right? Okay. So let's say we want to know, well, how long is this thing going to be in the air? Well, so what we want to do is solve this for when the height of the object is 0. So 49.59 t minus 16t squared plus 5 equals 0. Well, that's a quadratic if you've done this before. And if you do this, and you can check this later, you're going to find out the object is in the air for 3.20 seconds. Is how long my object will be in the air. Right? Well, how far does it travel? Well, in the x direction, this will be given by 136.26 times 3.20. And we find out it travels 436 feet in the x direction. Okay? Then we want to know, well, how long does it take to reach max height? And so it ends up that the time up is given by the initial velocity in the y direction divided by g. And so this is going to be 49.59 divided by 32. And so the time it takes to go up is going to be 1.55 seconds. So the max height will occur at that time. So max height is going to be given by this. So y is going to be 49.59 times 1.55 minus 16 times 1.55 squared plus 5. And it gets a maximum height of 43.43 feet. Right? So we have in regards to a parametric equation. Right? And that will conclude this video.